Now today we're going to talk about the sum of a finite series. Now remember, a series is just a series of numbers, and if we're taking the sum, remember the word sum means addition. So we're just going to be adding all of the numbers in the series together. And notice that today we're focusing on finite series, or in other words, a series that has an end. In our next assignment, we'll be working on infinite series. But for now, we're just going to work with finite series. So if you look at our first example, it says to expand the series and then evaluate. So the first thing you need to notice is we've got this big block E thing going on. Now this E is the Greek letter epsilon, and it's the symbol we use when we want to find a sum. So we're just going to find a sum. And notice down here it says that k equals 1. This is our starting point. We're going to start out when k equals 1. Now usually when we start with 1. We can change that number, but typically we do start with 1. Now this number up here, in this case it's a 5, that tells us how far we're going to go. In this case, we're going to write out the first 5 terms of the series. And then this right here, this 3 times 2 to the k minus 1, that's the equation we're going to write. So if I want to expand the series, I'm going to start by writing it as 3 times 2, and then my first k, remember, is the number 1. So 1 minus 1 power, plus 3 times 2 to the 2 minus 1 power, plus 3 times 2 to the 3 minus 1 power. Notice how I'm just counting, and I'm going to keep going until I get to this number they told me, which was 5. So 3 times 2 to the 4 minus 1 power, plus 3 times 2 to the 5 minus 1 power. So here's my series all written out, but now I'm going to go ahead and simplify this. So this becomes 3 times 2 to the 1 minus 1 is 0 power, plus 3 times 2 to the 2 minus 1, or first power, plus 3 times 2 to the 3 minus 1, or second power, plus 3 times 2 to the 4 minus 1, or third power, plus 3 times 2 to the 5 minus 1, or fourth power. Alright, well if I worry about those powers, in this first term I know that 2 to the 0 power is 1, so this is actually 3 times 1. Plus 2 to the first power is 2, so this is 3 times 2. Plus 2 to the second power is 4, so 3 times 4. Plus 2 to the third power is 8, so 3 times 8. Plus 2 to the fourth power is 16, so 3 times 16. Now I'm going to go ahead and multiply that out. 3 times 1 is 3. 3 times 2 is 6, 3 times 4 is 12, 3 times 8 is 24, and 3 times 16 which my calculator is telling me is 48. So when it says to expand the series, it's looking for this right here, the 3 plus 6 plus 12 plus 24 plus 48. But notice how then it also asked us to evaluate. In other words, it wants to know what this equals. So I'm going to go ahead and add that together, and I'm just going to use a calculator. If you don't have a calculator, you can type it into Google, and Google will act as a calculator for you. But when I type this into my calculator, I get that it equals 93. So when it says to evaluate by expansion, that's how you would do it, is just type that into your calculator. Well, as you can imagine, this can get kind of cumbersome if we go very far. So we actually have what we call the sum formula that we can also use to figure this out. Now that sum formula is written right here for you. And in this formula, S sub n is the sum. it's what we'll get when we'll add all these numbers together. A sub 1 is the first term, and you notice that it's written right here in our little sum equation. R is the common ratio, or in other words, it's the number we're multiplying by each time. And notice that that is in this parentheses right here. There's our R. And then N is the number of times, or the number of terms, that we're going to. And that shows up here on top of our sum. So knowing that, I can go ahead and solve the exact same problem using this sum formula. So to do that, I'm going to say that S sub n, the sum that I'm looking for, is equal to A sub 1. Well, that A sub 1 in this problem is the 3. Times parentheses 1 minus R, which is my 2, to the n power. Well, in this case, my n is that 5. All over 1 minus R again, which was 2. Now, to solve this, I'm going to go ahead and do it piece by piece, but if you have a calculator that allows you to type this straight in, you can go ahead and just type it straight into your calculator. But if you don't, we can solve it piece by piece. So I have 3 times 1 minus 2 to the 5th power, which is 32, all over 1 minus 2, which is negative 1. All right, well, if I simplify that down, I'll have 3 times 1 minus 32, which is negative 31, all over negative 1. Well, the negative in my numerator and the negative in my denominator will cancel each other out, and this becomes just 3 times 31, which is going to equal 93. And you notice that we get the same answer that we got before when we actually wrote the terms out and summed them, which is what you would have expected, but it was a little quicker using our sum formula. So once I know how to use that sum formula, I can also use it to figure out the first term of the series, which is what we're asked to do here on example 3. Notice it wants our first term, which is the A sub 1. So they told me my S sub n, my R, and my n, so I'm going to be plugging those into my formula. Remember, the formula was S sub n equals A sub 1 times 1 minus R to the n, all over 1 minus R. So I'm just going to plug the numbers that they gave me into this formula. I know that S sub n was 13,120. That equals my A sub 1, which is what I'm trying to figure out, times 1 minus R, which they told me was 3, to the n, or 8th power, all over 1 minus R, which is 3. To solve this equation, I'll have that 13,120 equals A sub 1 times 1 minus 3 to the 8th power, which is 6,561, all over 1 minus 3, which is negative 2. I'm going to pull this problem up here. And now if I solve it, I have 13,120 is going to equal A sub 1 times 1 minus 6,561, which is negative 6,560, all over negative 2. Now again, my negatives are going to cancel, and I get that 13,120 equals A sub 1 times 6,560. If I divide that by 2, I get 3,200. 280. Now to get the a sub 1 alone, I'm just going to divide on both sides by 3,280. And if I type that into my calculator, my calculator tells me that it equals 4. Okay, so there's our example 3. Last but not least is the story problem that we're going to talk about now. It says, in the first hour, a forest fire consumed 3 acres of forest. The next hour, each acre burning spread to 2 more acres. If this pattern continues, how many acres of forest will have burned in 6 hours? Now, what I'm looking for here is the sum, how many acres will have burned. So I'm going to use my same sum formula that I've been using. So here's the formula. And S sub n is the sum that I'm trying to find. A sub 1, remember, is how much we started out with. Notice it says that we originally consumed 3 acres of forest. So my A sub 1 is 3. R is my common ratio, or the number I'm multiplying by each time. It says the next hour, each acre burning spread to 2 more acres. So my rate is 2. I'm multiplying by 2 each time. Then the last thing I need to know is the n. It's how long we're going to be measuring. This says if this pattern continues, how many acres will have burned in 6 hours. So I know that my n is 6. Well, once I know that, all I have to do is plug this into my formula. So I'm going to have the S sub n equals A sub 1, which was 3, times 1 minus my r, which was 2, to the n, or 6th power, all over 1 minus r, which was 2. If I simplify this equation, I'll have 3 times 1 minus 2 to the 6th power, which is 64, all over 1 minus 2, which is negative 1. If I continue simplifying, I'll have 3 times 1 minus 64, which is negative 63, all over negative 1. Well, my negatives are going to cancel, and I just get that S sub n is equal to 3 times 63, which if I type that into a calculator, I get that S sub n equals 189 acres of forest that will be burned in 6 hours. So that's how you do this assignment. Now that you've seen it, go ahead and try the assignment on your own.